All right, so what is the improper integral?
You never told us this year.
I'm gonna tell you now. So for example, that if I have this graph of 1 over x squared, so 1 over x squared is gonna look like this.
I think this is what it was.
And it's gonna go very flat very soon.
What equation is this?
This is a f of x equal to 1 over x squared. And let's just say if I want to find area of here, and let's go to infinite. Let's go to infinite. So infinite is, so do you think the area is going to be finite or infinite?
It's going to be infinite because like it never actually reaches 0, right? You know what I'm saying?
It's more like the decimal places keep like, you know, like for example, it's like 0.1, and then like if you go over, it's 0.11, and then just like it's like when you're adding the integral.
So we come to two concepts. One concept is whether there is something called diverge and converge. Okay, so we're gonna learn two new words today. Well, we're gonna learn two new words today. One is whether it's diverge or converge. So if you think this area is gonna be finite, that's called converge. So if the answer, the area, is equal to finite here, right? The answer is finite, then it's gonna be converge. If it's infinite, it's gonna be diverge. Okay, so diverge is easy.
That makes sense.
If it go to infinite, because there is no finite of number can be doing things. Now, before we talk about this problem, just talk about a simple series question. And the simple series question could be like, okay, 1 plus 1/2 plus 1/3 plus 1/4 plus 1/5, and keep on going to infinite amount of time. Do you think this is going to be finite or infinite? Okay. Now, if you don't know, I want you to do a comparison between this one. 1/2 plus 1/4 plus 1/8 plus 1/16 plus 1/32, and keep on going to infinite. Okay, which one is going to be finite and which one's going to be infinite? Okay.
Yeah.
What are you doing here? Shut up. Go away.
Apparently Cass is in here. Yeah.
What happened?
Our stats teacher that we collectively share.
Cass is not here?
I guess not. Stuff looks like that, but so it could be wrong.
Oh, that's fun.
Do you miss calculus?
I like this better than stats though. Stuff harder, stats definitely easier.
The graded stats I like better.
Yeah, I like my graded stats better, but this not.
Yeah.
Mm-hmm.
That's definitely harder.
Okay, then. Don't lie.
So if you don't know, it turns out this series, this one is actually infinite.
Yeah.
This is not gonna be bound by, if you adding all up, it's gonna be infinite. So therefore this is called a diverge, because it doesn't conclude into one number. Think about it. If you have one pizza plus half a pizza plus 1/3 a pizza plus 1/4 a pizza, 1/5 a pizza, 1/6 a pizza, 1/7 a pizza.
I'm getting hungry to share.
If you keep on adding all this pizza, is eventually is gonna keep on going. It's not gonna stop. But if I just twist a little bit, just twist from this to 2, 4, 8, 16, you'll find out this actually gonna be finite. What do you think the number is going to be? Why 2? You're right, Derek.
Oh, because the one's in front, so all that has to equal another one.
And there, what is this, right?
Yeah.
So you got 1/2 a pizza here, and you got 1/4 of pizza, you got 1/8 of pizza, 1/16 of pizza. It keep on adding. It's just cut it each time by half. Just like if I give you a pizza, right? And I says you only can eat half compared to prior day. So
You just keep eating 1/2 of the last piece of pizza, and you keep eating 1/2 at a time.
Eventually you'd run out.
eventually you're not gonna run out. You're just gonna finish the whole pizza.
You're just gonna finish it. And
You take a half bite, a half a bite, or half
Eventually
bite.
the slice is gonna be
Brad.
better
Well,
than the
you,
pizza
well,
cutter.
like, you can't slice a pizza
I think
infinitely.
Well, technically you can slice to atoms if you really want to.
Now we're getting
And there's
Ant-Man.
6.23 times 10 to the 23
Or-
items.
Quirks.
Oh, quirk.
Those are the smallest little things.
Yeah.
You can't slice them.
We
just
just
talked
leave
about
the
that
part
earlier.
that you can, because they're made of
So shh. This is a finite. If a finite, shh, if this is a finite, then that means this is gonna be converge. So today we're gonna focus on the thing that's converge, even if it goes to infinite. And this question, it does. So let's talk about improper integral. What are the 3 conditions that improper integral had to exist in order to have improper integral? So I'm gonna write it down. So those are very, very important conditions. It looks really easy, but it's very important. So here it is. First condition. If f is continuous, it has to be continuous, and between bracket a to infinity, then integration of a to infinity of f of x dx is equal to, now for me that you never should be like this, after infinity. That doesn't make sense. You cannot just integrate and plug in infinity, so that doesn't make sense. So this is not a good notation for math, because you gotta do FRQ. So what's a good notation? If I want to approach infinity, I'm gonna assume that there is a number called b. So therefore it's gonna be b approaching infinity at the integration between a to b of f of x. So that's just the way you write it out. So this one need to be there. You need this. Need. You must have. Sorry, must have. Required, thank you. Okay, you need to require that because technically you cannot do integration to infinity. But if the limits b approach infinity, then that is okay to have. Okay?
You're running infinity instead of 100 instead of infinity.
So second thing says if f is continuous on the interval between negative infinity to b. Why is it negative infinity to b? Well, this is bracket, sorry. Should be the other way around. This is bracket. Then integration between negative infinity to b of f of x dx is equal to limits as a approach to negative infinity, because we're going to assume the bottom is a into b now of f of x dx. So this is the second condition. If one of the boundary is going to infinity or negative infinity, we're going to assume that number is approaching a or b. Depends on its upper bound or lower bound. Now I can reach that by using limits. The third condition is this. If f is continuous between negative infinity to infinity,
Wait, are you saying all three of these conditions need to be fulfilled, or these are three separate?
No, that's three separate conditions. Three separate situation, three separate conditions. So if I have a negative infinity to infinity, which is some of you guys taking statistic, you do see the situation in normal distribution curve. Normal distribution curve is area under that curve has to be equal to 1. And there was a proof for that. And I don't know that proof, unfortunately, because I'm not smart enough. But I saw that proof before on YouTube. Reciprocated, I'm not smart enough. So therefore, I'm just going to say, look it up somewhere if you're interested. But this, you can break up to two separate integral. Negative infinity to c. C has to be between a and b. F of x dx. Now, I would arrange the c to some number that you feel more comfortable with. Because if there's some number easier to work than the other, usually 0, but doesn't have to be 0. Okay, but
Don't do that. Don't do that. Stop.
what the hell just happened?
I thought that was directly in your eye. He had the Allen wrench. I just did like.
Okay, we
Yeah,
get it.
So I just look up and I see the things, and it looks like it's sticking in his eye.
So weird.
And I know Andrew was doing something like that.
Okay, so we're gonna try that problem, and that you have to write it properly because you have to have the limit piece, right? So if I say it's integration, because we're trying to find this area between 1 to infinite, and we say, okay, that's doable. It's 1 to infinite.
This is a practice problem.
Yeah, this is the first practice problem you're gonna see. 1x. That's equal to, well, we say that infinity is not possible. So we're gonna say that is a value of b. And this one is gonna be 1. And this one is gonna accompany with limits as a b approaching infinity. Of,
X squared.
yep, x to the negative 2 dx. If I integrate that, what will happen? Will be x to the negative 1 over negative 1, right? Between
You could just say, okay.
b and 1, limit as b approach infinity. Now remember, you do need this present. Otherwise, it won't be improper integral anymore. So that's going to be negative and 1 over b, wait, negative 1 over b, right? Minus negative 1 over 1.
Well, why do you have the negative on the outside? I'm sorry. Why do you have the negatives on the inside if there's already a negative on the outside?
Good question. So they should not have a negative sign. Wait, hold on a second. You shouldn't. Yeah, it's fine. So this one is here, and this one is here. 0. And with limits b approaching infinity. What happened when limit with b approaching infinity? That's going to be negative 0, right? Minus 1 over 1, and that's equal to 1.
Wait,
That makes sense, actually.
1 over infinity? Minus 1.
Did you ruining his note?
Andrew, stop it.
I'm surprised I didn't Leo, but
Okay, now if you got your answers infinite, that means it's diverge. Okay, so sometimes you will get an infinite. That just means diverging. So you can have possible have diverging. So I want to give you a couple situations. First situation is 1 to infinite dx over x. So that is a first situation. Second situation, I want an infinite between 0 to infinity, e to the negative x dx. Third is going to be 0 to infinite, 1 over x squared plus 1 dx. So the first one is the easiest one. So let's see if you guys can figure out.
Shay, we have like 1 minute.
Oh, we do?
Yeah.
Okay, then we continue tomorrow. So go into part 2.
The first one is infinity.
The first one is infinity. Because you are gonna get limits as a b approach infinity of natural log of x between 1 to b. So therefore it's gonna be natural log of b minus natural log of 1 with limits b approach infinity. And that natural log infinity is just going to be infinity minus 0. So it's infinity. So it's actually diverge. Okay, so we finished the first one. And then,
Did you just say it diverged like at the answer?
yep, that's going to be diverge.